Let's check the sample source that communicates data. I will explain with memory C in the sample folder in the SDK, in the setup folder, within the installation folder. The sample source consists of receive and send. And let's run the program. Left side is master PC, right side is slave PC. Run the slave first. And then run master. Data is sent from the master PC and received from the slave PC. This is a sample source that repeats a total of 100 times. This data is a sample source that allows users to enter and transmit desired data. And the master PC on the right shows the read speed, and the right of the master PC shows the data write speed. Please note that data speed may differ depending on the data size or environment. I will review the send and receive sources together. Global variables are set in advance when starting the program. Settings can be changed depending on the customer's environment. Gboard index is the index of the GiGA Connection board currently connected to the PC. If there is more than one board, you must use it while changing the numbers. G-Link channel sets how many channels to use via optical cable. 0 uses only one channel, 1 uses two channels. GMyNode ID is the node ID of the board. The board's node ID is initialized to 0 when the computer starts. Please set it from 1 to 31 excluding 0. Gtarget node ID is the ID information of the place where data is sent. The node ID of the send source is 1, and the target node ID is 2. Since the node ID of the receiving source is 2, and the target node ID is 1, you can see that there are sample sources that communicate one-on-one with each other. Set the mailbox number with Gmailbox. Mailboxes can be set from 0 to 31 and can be used by adding 32 bits of data. In addition to sending and receiving data, the mailbox is also used to perform node connection and synchronization control. In send source, there are G-memory number and G-memory offset. APX 740 02 is equipped with 4 GB of memory is divided into areas of 1 GB. Memory area can be set to 0 to 3. Memory area 0 can be showed as an area from 1 to 1 GB, and memory area 1 can be showed as an area from 1 to 2 GB. G memory offset must also be entered in hexadecimal in 4-byte units. For example, when 10 MB of data is continuously stacked in memory, the value of memory offset must be changed so that the data can be stored without overlapping. G data size enters the size of data to be sent or received. Please enter hexadecimal numbers in 4-byte units in the range from 4 to 0 by 40 million. G buffer is an actual data being sent or received. Likewise, please enter in 4-byte units. In the sample source, random data is set. Let's go to the main page. The sources starts from the main and first displays the information set as global variables. The source runs in a total of 4 steps. Send consists of initialize to recognize board hardware, link node initialize to configure the link, send data to send data, and finalize to terminate the source. All receive sources are the same, with the only difference is wait receive is used instead of send data. For reference, detailed information about the function can be found in the APX 7402 library manual. First, initialize and read board information in APX 7400 initialize. APX 7400 get board count reads the number of GiGA boards connected to the PC. If the board is not recognized, the source will terminate. If more than one board recognized, information on each board is obtained from the for statement below. When you enter board index information into APX 7400 get board info, information is created in INF and the source representing that information is below. APX type, optical channel information, memory area, memory size, dip switch, board temperature, FPGA temperature, FPGA version, driver version, library version. You can see. Link node initialize. You can get information about node configuration. This is a variables item for node configuration. First, when running APX 7400 receive mailbox, initialize the mailbox by entering default values. Enter APX 7400 set node ID to set the node ID. Get node ID information from APX 7400 get node ID. This is a while statement to configure APX 7400 get linked nodes, and the sample source continues to execute this function until the nodes are configured. Since the sleep below is 3 seconds, I will call a function that gets linked node information every 3 seconds. When identical links occur, overlap information is displayed and link configuration ends. If a different node ID is recognized in the optical module, it terminates. The third function is different each other. I will explain send and receive together. Please refer to the send data function and will receive function. Both set the variables needed for communication. Return is a variable to check the return value of the function. Since we mostly use the global variables values explained earlier, we will omit the explanation of variables containing G. Mailbox data is mailbox data. Offset and no values initially receive values set as global variables. Mailbox receive is the data received, not used in this sample. Buffer receives the value of G buffer. It is the most important source in this sample. Data communication is possibly by writing and reading data such as letters, numbers, files, and the images to this buffer pointer. Max loop is a variable for communicating data 100 times in the sample source. Timeout is set as millisecond, and you can set the time received mailbox waits for an event. This sample source is 60 seconds long, so waits 1 minute. The rest are incidentals other than communication. There are starts and end variables for receiving status information, data location, loop, and time measurement. First, if buffer is null, it returns. Data is generated in 4-byte units. Create a loop to send data 100 times. Send data to write target memory. For more information about the function, please refer to the manual. Among these functions, data is passed to the buffer item. Afterwards, the receive mailbox function is used to receive an event indicating that data has been received on the receiving side. If timeout does not occur and there are no errors, increase the loop value and run 100 times. Receive is same and the variables are same. When we look at the source on the receive side, it starts a loop 100 times right away. Wait for the mailbox sent from the send side. In this sample, the values of mailbox number and mailbox data are received from write target memory on the send side. Afterwards, create data in 4-byte units and check the memory offset value. Read data from APX 7400 read my memory. The buffer of this function contains the values sent from the send side. If received normally, an event indicating successful reception is generated on the send source side. Likewise, if there are no errors or timeouts, it repeats 100 times. And finally, end the board in end processing. Shut down the board and release the buffer. This is an example program. On the left transmitting side, there are frame grabber and GiGA connection board for video acquisition, and on the right receiving side, only GiGA connection board is installed. The data acquired from the frame grabber's image acquisition callback is input into the buffer of the write target memory, and the receiving node reads and displays the image through read my memory. Not only video but also all data can be used as a buffer can be used.